Hello, in this video I'm really going to show you how to solve exponential expressions, and these are equal or equations, and you may say, oh man, just seems impossible. How in the world am I going to solve for x here? The method that often works, it doesn't always work, but it often works, is method of trying to level the playing field, I call it. And this really requires us to try and make the bases on each side equal. So 5 is already a base on the left side. 125 on the right side can actually be written as 5 to the exponent 3. So this is a really good way to do it, because I mean I can, and then I can have the exact same bases on the left and the right side. Now on the right side I've got an exponent on top of an exponent, which means those will multiply. So I'll just really rewrite it as 3x on the right side for my exponent. Now as soon as I have the bases that are equal, base on the left side is 5, base on the right side is also 5, I can in fact just drop them, because if the bases must be equal, well then the exponents must be equal. So I can just really focus on exponents. All right, so I can really just say, well, x plus 3 must equal to 3x without worrying about what the bases are anymore. And this actually now makes it really easy to solve for x, because I can really just move things around. So move both the terms with an x on one side and collect like terms. I'll get 2x is equal to 3, and then I'll divide both sides by 2 and get x is equal to 3 over 2. In example B, I've got 3 to the exponent 2x and 243 to the exponent x minus 5. On the right side, I can rewrite 243 as 3 to the exponent 5. And as soon as I do that, I can, again, multiply 5 with x, but then also 5 with negative 5. And make sure that you do that. That's something that people will often forget. And on the right side, I'll end up with 3 to the exponent 5x minus 25. And now, again, I've achieved the leveling of the playing field. I have both exponents the same, both bases the same, so exponents can be made equal. And again, we're going to go ahead and do algebra, collect like terms, and move things around, and then divide by 3 to learn that x is equal to 25 over 3. This can be made a little bit more challenging if I have something like 3 to the exponent x squared plus 1 is equal to 1 over 9 to the exponent x plus, 4. All right, so here there's two things. First of all, the exponent has an exponent, so that's next level foolishness. And on the right side, I have 1 over 9. Well, that 1 over 9 can really be written as 3 to the exponent negative 2. Sorry, negative 2, right? Because 9 is really 3 squared. And then if I bring it up to the numerator, it becomes 3 to the exponent negative 2. So there we go. I've got that. And then I can multiply the same way that I've done in example B. So the left side, I'm leaving it unchanged. The right side now becomes 3 to the exponent negative 2x minus 8. Remember to multiply both in. And now I can drop the exponents and end up with x squared plus 1 is equal to negative 2x minus 8. And here, what I can do is, again, I'm going to move things around, but because I have the exponent 2, what you have to do here is you have to move everything to one side. Write all of your terms with x in decreasing order. So you see I've got x squared first, and then 2x second, and then I have plus 1 plus 8. The 8, when it goes to the right side, becomes positive, so it'll become 9. And that's going to be equal to 0. So if I stop here, or if I get it to this stage, this should now start to look a little bit familiar. This is a quadratic. I can solve this two ways. You can either factor using product sum. I don't think that'll work in this case, because you have to think about what two numbers multiply to 9, and also at the same time add to 2, and I don't think those two numbers exist. And then the second way is to use the quadratic formula. That'll always work, okay? You can even use a quadratic formula calculator, which I'll probably do online, or we can complete the square. Complete the square. And how in the world would I do any of those things? So I'm going to just focus on using quadratic formula, because I feel that might be the default way people will go and solve this if it has a solution. So when I use the quadratic formula, that's my method of choice, I have to write out the quadratic formula. So I'm going to do it right here in the middle. quadratic formula is really x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And before I do the entire quadratic formula, I like to use my discriminant first, the stuff underneath the square root sign, because if that's negative, that expression actually will have no solution, right? So let me even see if I have a solution. So what is square root of b squared minus 4ac? Well, in this expression, 1 would be my a, 2 is my b, and c is equal to 9, right? So b is 2, so that'll be 2 squared minus 4 times a is 1, and c is 9, and that will really become 4 minus 36, and yep, that's the case, negative 32. This is negative. Because my discriminant is negative, this does not have any solutions, okay? So I would stop right there. If it did have a solution, if this was positive, I would continue on with my quadratic formula and try and figure out what those two solutions were. You could complete the square as well, but you will not get a solution in this case because there just isn't one, which is fantastic. I do like using quadratic formula or factoring by product sum, but only if you can do it. Thanks so much for watching.